So this is what you draw. You draw this, you draw the surface, you put the normal there, you keep the cable intact, and you put the tension, normal, and then you put the weight. Is this correct? No, because what's going on here? There's an equal and opposite normal. The ground is causing a normal onto the ball, the cylinder, and the cylinder is causing an equal and opposite normal. When you have these things intact and they're not separated, there is a normal going in both ways, and they cancel each other out. So when there's touching, there is no drawing. You don't draw anything because it's internal to the system, right? It's only when it's separated that you have to account for that. Does that make sense? So here, when I draw the free body diagram of the total structure, notice I'm not drawing the ground. I'm not showing that little thing that's coming out of the ground that's connecting, because I just separated it. Same thing over here. I separated it. I'm drawing only the member, and it has a normal going up. Okay, so on the quizzes, I noticed people are still drawing the ground. You can't. It's not correct. There is, I guess the weight is still there, I guess. But the tension's not there either, because it's pulling in both directions. It's internal. This tension here is internal to the system. You have to cut it. It's not until you cut it that the internal force becomes an external force, and then you could solve for it. So from now on, nobody's going to draw the ground for me anymore, right? Kyle?
What if it's drawn with like a dashed line so that like the location is shown, but it's not a part of the
Oh,
body?
you mean like this?
Uh-huh.
I guess you could do that, because what you're trying to do in the end is show me the 90 degrees, right? Yeah, that's fine. Right? Because you're going to have to show me that it's 90 degrees, so I guess you're going to want a line or something. But with the tension, yeah, you don't, well, I mean, you could go like this, I guess. I guess you can do that, dashed and a dash. What's the point, though? I don't know. But you can, as long as you're showing that it's not physically there anymore. It's like a ghost. Okay, so DJ, did you get that now?
Yeah, that makes sense. And one other thing, so
Yeah.
on the one on the right on the board.
Okay, this one, let's you guys, when you refer to free body diagrams, give me the name, because we are getting into practice now where we are labeling free body diagrams, right? So in free body diagram, A, B, C, E, C, D sounds a little too long, but that one.
So should you not be writing CX then, because it's in the middle and it's internal, or?
No, I am, because this whole member is one member. It's not two pieces that are connected. This joint here connects with this. So when I separate this member from here, it experiences the CX or CY.
Okay.
But if I had this, if I had two members that were connected, right, put another one up. So here, let's say we had this. Oh boy, we're going to have a complicated problem like this on Tuesday. Okay, so we have three things coming together. When Lonnie separates her hand, I have to account for that. So we'll call them CX and CY. When these two separate, there's another CX and CY prime. Put them all together. But the total pin, there's one pin connecting all three things. And that pin is going to have to resist CX plus CX prime and CY plus CY prime. It's complicated. But we didn't do on Tuesday we'll do some complicated frame problems. But pretty much, once we finish this, which we finished this today, we have finished the third section of the course. Okay? And you are ready now to take that test. Or maybe not now, because you still have to do the 3D homework. You still have to do the 3D homework. But I'm moving on to the next topic that isn't on this exam, but you can see that it's the same kind of stuff, it's just a little bit more complicated. And then frames get a little bit more complicated when three things are coming together, and I'll show you problems like that. So is everybody, so I really think that you did this workshop, right? Evan, just give everybody credit for the workshop, okay? So you guys did this workshop, do not turn it in, because I want you to look at it. And you should go home now and actually do the equations that we did. We said, all the equations we did, what did we do? We did some of the forces in the x with this free body diagram to get ax. We did some of the moments about d to get ay. We went over here and we did some of the moments here to get ex. We did all that. Do that. Practice that. Because it's going to help you for the exam. The more efficient you can solve these problems, the faster you go. Okay? In addition, Evan, you have that quiz now?
Oh, it's up there.
Oh, thanks. So in addition, the quiz on Tuesday, that's graded. I graded most of it, but then I had Evan